We continue looking at angles and arc measures in circles. In the lessons 2 and 3, we looked at angles that were formed only inside the circle. We looked at central angles where the vertex is on the center, and we looked at inscribed angles where the vertex is on the circle. Now we're going to look at angles that are formed by chords, secants, and tangents. So, how do I find angle and arc measures using chords, secants, and tangents? All right, to begin with, we're going to look at what happens when the angle is formed inside the circle. Okay, so in this case, we have two secants or two chords. Remember that a chord is the part of a secant that is inside the circle. So a secant starts outside and ends outside the circle. The chord starts on and ends on the circle. So if two secants or two chords intersect inside the circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arc and the angles, vertical angles, intercepted arc. So what in the world does that mean? Well, let's look at angle 1 here. The measure of angle 1 is going to equal half the sum of the intercepted arc, so the measure of arc AD, and the vertical angles intercepted arc, the measure of arc BC. Alrighty, if we look at angle 2, the measure of angle 2 will equal half the measure of arc AB, its intercepted arc, plus the measure of the vertical angles intercepted arc. Okay, remember that when we had a central angle, our arc measure was equal to the central angle. When we had an inscribed angle, the vertex was on the circle, the measure of the angle was equal to half of the intercepted arc. So whenever we're in the circle, we're dealing with half of the sum. That's important to remember. All right, Smartboard won't move on its own, having to walk over to the computer to do that manually. What fun this morning. So, how do I find arc and angle measures when the angle is formed on the circle? Okay, so to form it on the circle, we've got a secant and a tangent, and they're going to intersect at a point of tangency. That point is A. The measure of each angle formed is equal to half the measure of the intercepted arc, just like inscribed angles. So the measure of angle 1 is going to equal 1/2 the measure of arc AB. And the measure of angle 2 is going to equal half the measure of arc ACB. Okay, so when it's on, it's half the intercepted arc. In half the sum, on half the intercepted. Ooh, can't even turn the page. Great deal of fun with the Smartboard this morning. Let's see what happens when we are formed outside the circle. If secants and tangents intersect at a point exterior, outside of a circle, then the measure of the angle formed is equal to half the difference of the intercepted arc. So let's look at this two secants example. I want the measure of angle CAE. That is going to equal half the larger arc, measure of CE, minus the smaller arc, the measure of BD. You always do the larger one minus the smaller one because angle measures have to come out positive. All right, so the assumption is you're just going to subtract the smaller one from the larger one. All right, what if we have a secant and a tangent? So AB is our tangent and AD is our secant. Well, the measure of angle BAD is going to equal half the measure of the larger arc, BD, minus, and I'm going to pick up another color here, the measure of the smaller arc, BC. And I picked up the other color because point B was shared by both arcs, and it helps to see it separately. All right, so what if we have two tangents? We have tangent AB, and we have tangent AC. Well, the measure of angle, BAC, is going to equal half the measure of the larger arc, BDC, oops, minus the measure of the smaller arc, BC. So it doesn't matter how your outside angle is created. It's the same formula for all three situations. 1/2 the larger arc minus the smaller arc. So let's give a couple of these a try. Alrighty. Let's see. My angle, BEC, is on the inside. So I know inside means half the sum. Alrighty. So I have measure angle BEC equals 1/2. The intercepted arc is 109 plus, go vertical, and that intercepted arc is 45. So if I've done this correctly, that's 77 degrees. Try number 2 on your own, please. Pause your video. All right, so this time I knew the angle measure. I was trying to find the measure of the intercepted arc. All right, so the angle measure equaled half the sum of the intercepted arc and the vertical angle's intercepted arc. And then it was just a matter of doing some algebra. Let's see here. We've got a tangent and a secant, and this angle is on. When it's on, I know it equals half the intercepted arc. So CBD, we're talking this angle here. So I'm going to need to do half of this arc, but I don't have that arc. How can I find the arc measure for arc BD? Well, let's think about it. 360 minus 192. Uh, 168. Okay, So CBD is going to be half of 168. That's 84 degrees. Let's look at number 4. Number 4, my angle is out. And I know out is 1/2 the difference. So KLM, this angle, will be half the large minus the small. Equals 1/2 my larger arc minus my smaller arc. And that should come out to 37 degrees. All right. At the top of this page, pause your video and try number 5, please. All right, so I had to figure out the measure of arc AD. So I took 360 degrees for the entire circle and subtracted out the 2 arcs I knew to find that the measure of that arc was 210. So the exterior angle is half the difference. 1/2 210 minus 62 is 74. All right. Oh, lovely. Okay. Number 6. Number 6, 2 tangents. And look, we've got the big arc, right? This is going to be a half the difference problem. We have this one. It's 313. I'm missing PR. How am I going to find that? 360 minus 313? All right, so pause your video and try this one, please. Okay, 1/2 the difference, and the measure of angle PQR was 133 degrees. This last one, we know the answer. We're trying to find one of the arcs. And they're asking for EF, which is interesting. Let's make that X. That's what we're trying to find. And we're missing FH. Interesting. So we're missing this. I'm going to make this Y. Well, I can figure out Y. I know my exterior angle, 77 degrees, has to equal half the difference of the larger intercepted arc minus the smaller one. And I can solve that. Multiply both sides by 2, and I get 154 equals 191 minus Y. So Y is going to equal 37. Now I want X, right? And if X will equal the whole circle, 360, minus 191 minus 37 degrees. And that's 132 degrees. All right, for your summary, I want you to tell me what's the rule if the angle is formed inside, what's the rule if the angle is formed outside, and what's the rule if the angle is formed on the circle.